Today we're going to be talking about raising a monomial to a power. Please remember to take notes and jot down any questions that you might have so we can talk about them in our next class meeting. Also, feel free to pause the video at any time to practice anything on your own or to rewind it to see anything again. First, let's recall exponents. Negative 1 to the second power. If you remember, that negative is not included with the exponent of 2. So what we have is the negative 1 squared, so 1 times 1, which ends up being negative 1. Down here, we have negative 1 all raised to the second power, which is slightly different. Now what we're doing is we're taking that negative 1 and multiplying the whole negative 1 by itself. So what we end up with is a positive 1. 2x all raised to the third power, similarly to the one above, we want to take the whole base of 2x and raise it to the third power. So I have 2x times 2x times 2x. Now we multiply our coefficients. 2 times 2 times 2 is 8, while x times x times x is x to the third power. So this ends up being 8x to the third power. Similarly with xy to the fourth, all of that xy is being raised to the fourth power. So I have xy times xy times xy times a fourth xy. Multiplying all of my x's together, I have 1, 2, 3, 4, giving me x to the fourth power. Multiplying the y's together, I have y times y times y times y, which is y to the fourth power. Similarly with the one below, I have CB all raised to the third. So CB is going to be multiplied by itself 3 times. Multiplying the c's together, C times C times C is C to the third power, while B times B times B is b to the third power. Lastly, I have 2gh to the third power. Very similar. I take my base now of 2gh and I'm going to multiply that whole base by itself 3 times. So 1, 2, 3. Multiplying my coefficients, 2 times 2 times 2 is 8. Multiplying the g's, g times g times g is g to the third power. And multiplying the h's, h times h times h is h to the third power. If you look back over that right-hand column, you might be able to notice that with the exponent on the outside, all we've really ended up doing is putting that exponent on each of the individual terms inside. So I ended up with an x to the fourth and a y to the fourth power. Similarly, down here I put this 3 on the c and the 3 on the b. So I ended up with c to the third power and b to the third power. This third one is a little bit different because of that 2, but we did the same thing. 2 to the third power. We put the 3 on the g, so we have g to the third power. And we put that exponent on the h, so I have h to the third power. The only difference is that we multiplied out the 2 to get 8 instead of 2 to the third power. So that brings us to our rule. For monomials raised to an exponent, the exponent on the outside of the parentheses will be applied to each individual part of that monomial. So as you can see here, if I have AB, whatever our base is, to the power of n, I'm going to take that exponent and put it on each individual piece. So I end up with a to the power of n and b to the power of n. Go ahead and take a moment and pause the video and try the next 4 on your own. For the first one, you should have g to the 6th, h to the 6th. For the second, you should have 2 to the 4th, m to the fourth. When you multiply out that 2 to the fourth, you should get 16 m to the fourth power. For the third one, you should have 2 to the third, m to the third, and again, when you multiply out that 2 to the third, you should get 8 m to the third. And for the last one, you have 3 components, but you still do the same thing. Put that exponent on each of those 3 pieces. So I end up with 3 to the third power, w to the third power, x to the third power. And multiplying out my 3 to the third, I have 27, w to the third, x to the third power. Go ahead and take a second and try one more. When you're ready, go ahead and check your answers. Our second concept for today is raising an exponent to a power. Now this is slightly different, as you might notice, because our base has its own exponent. We are taking x to the second, and we want to raise that whole thing to the third power. So how this looks is we end up with x to the second times x to the second times x to the second 3 times. Now we're multiplying all 3 of these terms. So all we do, since they have the same base, is add those exponents together. 2 plus 2 plus 2 gives me x to the 6th power. Well, if you notice, 6 is simply 2 times 3. We added 2 3 times, giving us the 6. So that brings us to our rule. When raising an exponent to a power, you simply multiply the exponents. How it looks in your standard form. If you have x to any power, let's call that a, and you take that and you raise it to the power of b, then all you're going to do is multiply those 2 exponents together, and that is your new exponent. So for example, I have x to the 4th, that's my base, I'm raising it to the 5th power. What you can do is you can say, I have x to the 4th times x to the 4th times x to the 4th 5 times. And now that you're multiplying 5 terms with the same base, you simply add the exponents. 4 plus 4 plus 4 plus 4 plus 4, well, that's x to the power of 20. That would be the same thing as simply multiplying these exponents. Again, you may take your base of w to the 6th and multiply it by itself 2 times, as your exponent on the outside says to do. Adding your exponents together, because you're multiplying your bases, we get w to the 12th power. However, it would have been the same thing to simply multiply your exponents from the beginning, w to the 12th. So for this last one, I'm simply going to multiply. H to the 9th is being raised to the 4th power, so my new exponent on h is a 36. Now we're going to go ahead and put those 2 ideas together. As we said in our first few slides, an exponent on the outside simply gets applied to each of the individual components of the term inside. So what ends up happening is we have m to the 2nd, and we are going to raise that to the 4th power. We have n to the 3rd, and we are going to raise that to the 4th power. So I took that exponent and I applied it on both the m and the n. Well, as we just said on our most recent slide, when you raise an exponent to a power, we multiply. So we end up with m to the 2 times 4th power, which is 8, and n to the 3 times 4th power, which is 12. So our final expression is m to the 8th, n to the 12th. Down below, similarly, I'm going to take my 5, my exponent of 5, apply it on the w and on the x term. So I end up with w to the 4th, all raised to the 5th power, and x to the 3rd, all raised to the 5th power. When we raise an exponent to another exponent, we end up multiplying. So w has a new exponent of 20, while x, when we multiply the 3 and the 5, has a new exponent of 15. So your final expression, w to the 20th and x to the 15th power. Above on the right is very similar, except I'm taking my exponent of 3 and applying it on 3 separate terms. So I end up with 2 to the 3rd power, c to the 3rd, and I'm now raising that to the 3rd power, b to the 2nd, and I am raising that to the 3rd power. 2 to the 3rd becomes 8. C to the 3rd raised to the 3rd power becomes c to the 9th power. B to the 2nd raised to the 3rd power becomes b to the 6th power. So our final expression is 8 times c to the 9th, b to the 6th. Down below, again, very similar. I'm taking that exponent of 2 on the outside, applying it to my negative 2, to my f to the 6th, and to the g to the 4th terms. So I have negative 2 raised to the 2nd power. Be very careful. I put it in parentheses because, as we've talked about before, if I do not put it in parentheses and I simply write negative 2 squared, this is only squaring the 2, not the negative as well. But I want to be sure to square the entire base of negative 2, which is why I write it in parentheses. F to the 6th is going to be raised to the 2nd power, and g to the 4th is also going to be raised to the 2nd power. Negative 2 squared becomes positive 4. Negative 2 times negative 2 is a positive 4. F to the 6th raised to the 2nd becomes f to the 12th, and g to the 4th raised to the 2nd becomes g to the 8th power. So your final expression is 4 f to the 12th, g to the 8th power. Please go ahead and pause the video to try these next 4 on your own. First, you should have m to the 35th power, n to the 14th. Second, you should have had 27, c to the 12th, b to the 15th power. Below, you should have had w to the 42nd power and x to the 18th. And lastly, you should have had a positive 4, f to the 6th power, and g to the 12th power. Again, please take a moment to pause the video and try these next 4 on your own. For the first one, I do want to point out that there is a negative 1 in front of your k squared. So you should have, in this one, a negative 1 raised, and we're putting that 2 on it, to the 2nd power. Then you have k to the 4th, m to the 10th, after you apply that exponent of 2. The negative 1 in front should become a positive 1 times k to the 4th, m to the 10th, or simply k to the 4th times m to the 10th. To the right, you should have had a positive 25, p to the 8th, q to the 10th. Below on the left, you should have had a positive 16, y to the 8th, x to the 24th power. And lastly, you should have had a negative f to the 5th power, g to the 10th power. Thank you guys for watching. I hope you have an awesome day, and I will see you at our next class meeting.